Alhamdulillah Rabbil Alameen. We start with the first lesson of algebra for scientific command trunk. The first lesson is set of natural numbers n and arithmetics. This lesson contains 3 paragraphs: the divisibility in n, GCD or the greatest common divisor, LCM and or the least common multiple. Divisibility in n. Divisors. The set of natural numbers is noted as n contain all natural positive non-negative numbers 0, 1, 2, 3, 4, 5, etc. Definition: A and B, two elements from n, two natural numbers. If there is n such as b equal n times n, we say that b is a divisor of a. A is a multiple of b, or a is divisible by b. The three statements are the same meaning. So all those three statements have the same meaning, which means that a equal b times n. Note, the number 0 is a multiple for all natural numbers. Also, the number 1 is a divisor for all natural numbers. So, every number, for example 10, we can write like this: 0 equal 10 times one number, which is this number, is 0. So this means that 0 is a multiple of 10. And we can do that with each number. 0 equal n times 0. So 0 is multiple of n. And also, for each number, for example 10 equal 10 times 1. So we can read this as 1 divide 10. 1 divide 10. So we can say that for each natural number n equal n times 1. So even and odd numbers. Definition: the even number is every natural number which can be written as multiple of 2. So 2n is an even number. The odd number is at the opposite. The odd number we cannot write under the form 2n, but we can write in the form 2 times n plus 1. So the odd number we can't divide by 2. In the opposite, the even number we can divide by 2. So, application: determine the set of divisor of each number. We start by the first 120. divisor, we note the set of divisor of 120 by divisor of 120, which contain at first 1, because 1 is divisor of every natural number, is a divisor for each natural number. When we divide by 1, the quotient is 120. We can divide by 2, the quotient is 60. When we divide by 3, the quotient is 40. Divide by 4, the quotient is 30. We divide by 5, the quotient is 24. 24 times 5 is 120. We can also divide by 6, the quotient is 20. If we divide by 8 by 8, the quotient is 15. I think 15. And we can also divide by 10, the quotient is 12. So this is the set of divisor of 120. We can do the same thing with the second number, 58, the divisor of 58, set of divisor of 58. We can start by 1, the quotient is 58. If we divide by 2, the quotient is 29. And I think 29 doesn't have any divisor, and the set is closed there. We can also do the third question, the divisors of 310, divisor of 310. We can start by 1, 310, 2 is 155. 155 we can divide by 5. The quotient is, if we divide by 5, 31. 31. And I think this is the last question. So we can close the set. Second question. Determine the set of common divisor between 12 and 21. The set, the divisor of 12 and the divisor of 21. Set of divisor of 21. We can start by 1, 12, 2, 6, 3, 4. And for the other set of number, we can start by 1, 21, 3, 7. The set of common divisors contain 1, which is always is a common divisor. 2 is not common, but 3 is common. 1 and 3. And those are the common divisors. The third question. Given n, a natural number, and x equal to 2 times n plus 1, and y equal 4 times n plus 2. So show that x is an odd number and y is an even number. We have x equal 2 times n, 2n plus 7. we can decompose 7, so 2n plus 2 times 3 plus 1, and we can factorize by 2, n plus 3 plus 1. So we can take k is equal n plus 3, and then x equal to k plus 1. Then x is an odd numbers. For y, we have y equal 4n plus 2. Y equal 4n plus 2. We can factorize by 2. So 4n is 2 times 2n plus 1. We can take L equal to n plus 1. Then y equal 2 times L. Then y is an even number. For the last question in this application, prove that 3 divide x plus y. So x plus y equal, we have x equal 2 times n plus 7 plus y, which equal 4 times n plus 4. That's right. 2n plus 7 and 2n plus 4n plus 2 plus 2 here. So we can cancel the parentheses. 2n plus 7 plus 4n plus 2 equal 2n plus 4n plus 9. So here we have 6n plus 9. We can then factorize by 3, which equal 3 times 2n plus 3 times 3 equal 3 times 2n plus 3. Then x plus y equal 3 times 2n plus 3 and 3 divide x plus y, and this is the last question.